Hello students, I am Satya. Welcome to today's class. In today's topic we are going to see screw threads, screw pitch gauge, taps.
Screw threads. Let's see the objectives of this topic.
At the end of this topic you shall be able to state the terminology of screw threads, state the types of screw threads, screw thread terminology. First of all, let's see the glance of screw thread terminology chart. Screw thread terminology. Crest, root, flank, thread angle, depth, major diameter, minor diameter, pitch diameter, pitch, lead, helix angle, hand. Students, now let's see the detailed view of screw thread terminology. Parts of screw thread. Crest. The crest is the top surface joining the two sides of a thread. Root. The bottom surface joining the two sides of adjacent threads. Flank. The surface joining the crest and the root. Thread angle. The included angle between the flanks of adjacent threads. Depth. The perpendicular distance between the roots and crest of the thread. Major diameter. In the case of external threads, it is the diameter of the blank on which the threads are cut. In the case of internal threads, it is the largest diameter after the threads are cut that are known as the major diameter. This is the diameter by which the sizes of screws are stated. Minor diameter. For external threads, the minor diameter is the smallest diameter after cutting the full thread. In the case of internal threads, it is the diameter of the hole drilled for forming the thread which is the minor diameter. Pitch diameter, effective diameter. The diameter of the thread at which the thread thickness is equal to 1/2 of the pitch. Pitch. It is the distance from a point on one thread to a corresponding point on the adjacent thread measured parallel to the axis. Lead. Lead is the distance of a threaded component moves along the matching component during one complete revolution. For a single start thread the lead is equal to the pitch. Helix angle. The angle of inclination of the thread to the imaginary perpendicular line. Hand. The direction in which the thread is turned to advance. A right-hand thread is turned clockwise to advance, while a left-hand thread is turned anti-clockwise. Okay students, let's try the question session. Try to answer the following question in 10 seconds. What is the term? The top surface joining the two sides of screw thread. Option A, root. Option B, flank. Option C, crest. Option D, depth. Your time starts now. First of all, congrats to everyone who tried to answer the question. Let's see the correct answer. The correct answer is option C, crest. Let's move on to the next topic. Screw threads types and uses. Screw threads types of V-threads and their uses.
Let's see the objectives of this topic.
At the end of this topic you shall be able to state the different standards of V-threads, indicate the angle and the relation between the pitch with the other elements of the thread, state the uses of the different standards of V-threads. Different standards of V-threads. BSW thread, British Standard Whitworth thread. Bsf thread, British Standard Fine thread. BSP thread, British Standard Pipe thread. BA thread, British Association thread. ISO metric thread, International Standard Organization metric thread. ANS, American National or Sellers thread. BIS metric thread, Bureau of Indian Standard metric thread. BSW thread. It has an included angle of 55 degrees and the depth of the thread is 0.6403 into P. The crest and root are rounded off to a definite radius. The figure shows the relationship between the pitch and the other elements of the thread. BSW thread is represented in a drawing by giving the major diameter. For example, 1 by 2 inches BSW, 1 by 4 inches BSW. Uses. BSW thread is used for general purpose fastening threads. BSF thread. This thread is similar to BSW thread except the number of TPI for a particular diameter. The number of threads per inch is more than that for the BSW thread for a particular diameter. For example, 1 inch BSW has 8 TPI and 1 inch BSF has 10 TPI. Uses. It is used in automobile industries. BSP thread. It is also similar to BSW thread. The thread is cut externally with a small taper for the threaded length. This avoids the leakage in the assembly and provides for further adjustment when slackness is felt. Uses. This thread is recommended for pipe and pipe fittings. BA thread. This thread has an included angle of 47.5 degrees. Depth and other elements are as shown in the figure. Uses. It is used in small screws of electrical appliances, watch screws, screws of scientific apparatus. Unified thread. For both the metric and inch series, ISO has developed this thread. Its angle is 60 degrees. The crest and root are flat and the other dimensions are as shown in the figure. Uses. This thread is used for general fastening purposes. Unified thread of metric standard is represented in a drawing by the letter M followed by the major diameter for the cos series. Example, M14, M12 etc. For the fine series, the letter M is followed by the major diameter and pitch. Example, M14 into 1.5, M24 into 2. American National Thread. These threads are also called as seller's threads. Uses. It was more commonly used prior to the introduction of the ISO Unified Thread. Okay students, let's try the question session. Try to answer the following question in 10 seconds. What is the included angle of BSW thread? Option A, 57 degrees. Option B, 60 degrees. Option C, 55 degrees. Option D, 45 degrees. Your time starts now. First of all, congrats to everyone who tried to answer the question. Let's see the correct answer. The correct answer is option C, 55 degrees. Let's move on to the next topic. Screw pitch gauge.
Let's see the objectives of this topic.
At the end of this topic you shall be able to state the purpose of a screw pitch gauge, state the features of a screw pitch gauge. Purpose of screw pitch gauge. A screw pitch gauge is used to determine the pitch of a thread. It is also used to compare the profile of threads. Constructional features. Pitch gauges are available with a number of blades assembled as a set. Each blade is meant for checking a particular standard thread pitch. Material. The blades are made of thin spring steel sheets and are hardened. Some screw pitch gauge sets will have blades provided for checking British standard threads, BSW, Bsf etc. at one end and the metric standard at the other end. The thread profile on each blade is cut for about 25 mm to 30 mm. The pitch of the blade is stamped on each blade. The standard and range of the pitches are marked on the case as shown in figure below. Okay students, let's try the question session. Try to answer the following question in 10 seconds. Which material is used to make screw pitch gauge? Option A, high carbon steel. Option B, spring steel sheet. Option C, medium carbon steel. Option D, mild steel. Your time starts now. First of all, congrats to everyone who tried to answer the question. Let's see the correct answer. The correct answer is option B, spring steel sheet. Let's move on to the next topic. Taps.
Let's see the objectives of this topic.
At the end of this topic you shall be able to state the uses of hand taps, state the features of hand taps, distinguish between the different taps in a set, use of hand taps. Hand taps are used for internal threading of components. Features of hand taps. They are made from high-speed steel. The threads are cut on the periphery and are accurately finished. To form the cutting edges, flutes are cut across the thread. The end of the shank of the tap is made of square shape, for the purpose of holding and turning the taps. The end of the taps are chamfered, taper lead, for assisting, aligning and starting of the thread. The size of the taps, the thread standard, the pitch of the thread, the diameter of the tapping hole are usually marked on the shank. Marking on the shank are also made to indicate the type of tap, that is, first, second and plug. Types of taps in a set. Hand taps for a particular thread are available as a set consisting of 3 pieces. These are first tap or taper tap, second tap or intermediate tap, plug or bottoming tap. These taps are identical in all features except in the tap lead. The taper tap is to start the thread. It is possible to form full threads by the taper tap in through holes which are not deep. The bottoming tap, plug, is used to finish the threads of a blind hole to the correct depth. For identifying the type of taps quickly, the taps are either numbered 1, 2 and 3 or rings are marked on the shank. The taper tap has 1 ring, the intermediate tap has 2 and the bottoming tap has 3 rings. Okay students, let's try the question session. Try to answer the following question in 10 seconds. Which tap is used to finish the thread of a blind hole to the correct depth? Option A, first tap. Option B, taper tap. Option C, intermediate tap. Option D, bottoming tap. Your time starts now. First of all, congrats to everyone who tried to answer the question. Let's see the correct answer. The correct answer is option D, bottoming tap. Let's move on to the next topic. Machine taps.
Let's see the objectives of this topic.
At the end of this topic, you shall be able to state the characteristics of machine taps, name the different types of machine taps, state the features and uses of different types of machine taps. Features of machine taps. The 2 important features of machine taps are ability to withstand the torque needed for threading holes, provision for eliminating chip jamming. Types of machine taps. Gun tap or spiral pointed tap. Gun taps are especially useful for machine tapping of through holes. In the case of blind hole tapping, there should be sufficient space below to accommodate the chips. While tapping, the chips are forced out ahead of the tap as shown in figure. This prevents the clogging of the chips and thus reduces the chances of tap breakage. These taps are stronger since the flutes are shallow. The flutes of these taps do not convey chips. Flute-less spiral pointed tap or stub flute taps. These taps have short angular flutes ground on the chamfered end, and the rest of the body is left solid. These taps are stronger than gun taps. Flute-less taps are used for tapping through holes on materials which are not thicker than the diameter of the holes. Flute-less spiral point taps are best suited for tapping soft materials or thin metal sections. Helical fluted taps or spiral fluted taps. These taps have Spiral flutes which bring out the chips from the hole being tapped as shown in below figure. These are useful for tapping holes with slots. The helical end of the tap will bridge the interruption of the surface being threaded. The helical flutes of the tap provide a shear cutting action and are mostly used to tap holes in ductile materials like aluminium, brass, copper, etc. Spiral fluted taps are also available with fast spiral as shown in figure. These taps are best suited for tapping deep holes as these can clear the chips faster from the hole. Thread-forming taps or fluteless taps. These taps form threads in the hole by displacing the material and not by cutting action. These taps have projecting lobes which actually help in forming the thread. Since there are no chips in the process, it is very valuable in places where chip removal poses problems. These taps are excellent for tapping copper, brass, aluminum, lead, etc. The thread finish is also comparatively better than in the fluted taps. Okay students, let's try the question session. Try to answer the following question in 10 seconds. Which tap is especially useful for machine tapping of through holes? Option A, fluteless spiral pointed tap. Option B, gun tap. Option C, helical fluted tap. Option D, thread forming taps. Your time starts now. First of all, congrats to everyone who tried to answer the question. Let's see the correct answer. The correct answer is option B, gun tap. Let's move on to the next topic. General informative points on taps.
Let's see the objectives of this topic.
At the end of this topic, you shall be able to differentiate between hand tap and machine tap. Identify the parts of a machine tap. State the constructional features of a machine tap. Unlike tapping with the three-piece set of hand taps, the machine tap cuts the entire threaded profile in one operation. The machine tap is normally made of tool steel. It consists of the shank, indicated as 2, and the cutting section, indicated as 1, in figure. The cutting section itself is subdivided into two areas. The start, indicated as 3, which serves for cutting, and the guiding section, indicated as 4, for the feeding motion and smoothing of the newly cut thread. The number of flutes, indicated as 5 in figure, may be even or odd. With an even number of flutes, measuring of the diameter, indicated as 7 in figure, is easier. Straight and spiral groove machine taps are available, as shown in below figures. The diameter of the shank and the shape of its end vary between the various standards. The shank diameter may be smaller, equal to or larger than the thread diameter. The shank ends are available in straight design, with square ends which is indicated as 6 in figure or with driving shoulders. Chip removal, flow, takes place at the start of the tap. The rake angle must be adapted to the material to be machined. Hard and brittle materials require a small rake angle and soft materials need a larger rake angle. According to rake angle and materials, 3 types of taps are available. Type normal, with a rake angle of approximately 12 degrees. Type soft, with a rake angle of approximately 20 degrees. Type hard. With a rake angle of approximately 3 degrees. The normal type of rake angle taps can be used in most cases. The start must be ground symmetrical. Before using the tap, it is necessary to check that the cutting edges are not chipped, and all the edges are sharp. The hard type tap is used for tapping brittle materials like cast iron. In case a normal type tap is used on cast iron, the tap cutting edges get blunt soon and the tap cannot be used again on ductile materials like mild steel. The fine cast iron splinters wear the external diameter of the cutting edges of the tap, causing them to tend to become blunt, and when the same tap is used on steel, which is more flexible, it is elastically pressed away, indicated as 8 in figure. At the cutting point, behind the cutting edge, the material returns to the machine diameter. The depth of the groove also causes jamming of the guiding section of the tap, as in below figure. Okay students, let's try the question session. Try to answer the following question in 10 seconds. What is the name of the section marked as 3 in given figure of machine tap? Option A shank, Option B square end, Option C start, Option D guiding section. Your time starts now. First of all, congrats to everyone who tried to answer the question. Let's see the correct answer. The correct answer is Option C start. Okay students, I hope you have gained plenty of knowledge from today's lecture. Once again, let's see the glance of topics we came across today. Screw threads, screw pitch gauge, taps. Thank you.
For queries, visit www.nemelearningonline.in/moodle.